Hey, YouTube. How is it going? I hope all is well. I wanted to kind of pick up where we left off a little bit from last week when we were kind of talking about the new amp build. I was talking a little bit with Andy, and of course, he was giving me some hell about using KT88s and not building a 100-watt amp. And it did kind of get me thinking a little bit. You know, my quick and dirty math obviously shows that there's nothing wrong with it. Nothing absolutely at all wrong with what I was doing. But I decided to kind of go back and see, you know, is it the best use of $120 worth of tubes? Is it, you know, like little things like that, you know? Obviously, I'm trying to make more of a modular type of platform with this particular design. I want it to be one of those things where mainly you can have a 50-watt option or a 100-watt option. Running an amp at 50%, you know, when it's designed to run at 100%, just doesn't work. It's just not the same, right? The only way you can get that kind of wattage is with, you know, the amount of voltage it takes to get to that kind of wattage. So trying to fake it by turning off a pair of tubes or doing this or doing that doesn't really work. And with KT88s, you can get, you know, between 80 and 100 watts with two tubes. So you can't just turn them off, right? Like, it's just not that simple. So I decided to kind of just do a little more research, figure out if it's the best use of that kind of topology, and see if there was another better option per se. And if you recall, this is kind of what the dirty math that we did last week up on that. And I did get the tubes. They are here. And let me tell you, these things are freaking ginormous. So imagine that. That's a soda can right there. So one of these things, I mean, it's not quite the size of a soda can, but I don't know if most people haven't really played with these things all that much, but these things are pretty freaking fat. These are ginormous freaking tubes. So here's my Dr. Pepper, and there's that. Like, you can see it's almost a 12-ounce can. I'd say this is probably nearly an 8-ounce shot right here, something like that. But beautiful tubes, very heavy and solid. Fun tubes. They're great for hi-fi. That's more what they're known for. They kind of like running in ultralinear for most stuff, but obviously they're kind of meant for more hi-fi, high output kind of stuff. So they work great in amplifiers, just mainly because they just do the job, right? Like, their job is to produce a lot of freaking wattage and get stuff done. I am not expecting a bunch of you to come into this stream today. It was very impromptu. Things have not changed very much since the last time we have seen or spoken to each other. I did get all the wood stuff done as far as staining and prepping and all that fun stuff. I currently have one piece getting glued in right now, and then I got 3 more pieces yet still to go. Unfortunately, I got to wait for this one piece to get going before I can get 2 others going. Before then, I can get to the last, 4th and final piece. Once that is done, then it's just a matter of putting this stuff here in, and we're pretty close. This week is going to be kind of a bust, though, which is why I'm doing this video today. I have a big show coming up this weekend, and I need to spend most of my time this week prepping for that gig. It's pretty big, so I can't, there's no screwing around with that one. So, again, progress on the amp is slow lately, just mainly because I've been busy doing other stuff. I am about a month behind on that amp at the moment, which is unfortunate. It's weird how it kind of works. Like, you get 1 or 2 days behind due to some screw up or some, unexpected event. In my case, I had a water heater go at one point. I had the wife's water pump go out at one point. Like, all these little things. I went on a little vacation trip that ended up being a little bit, almost a week longer than I anticipated. So all these little things just stack up. So I see there might be one person in here. Thank you for coming in. Stick around. We're going to talk a little bit about just kind of the design process. We already talked about how you need to decide what wattage you want to go with, decide which tubes you're going to use that can do that kind of wattage, and then how to kind of extrapolate the the supply voltage or HT voltage that you need and the output transformer that you need in order to get there. Again, just kind of going backwards a little bit, I initially decided I was going to go with KT88s. I have since decided against that. I kind of feel where I'm running the amp, I'm going to be running them at about 50%, 2/3 maybe of their capabilities. Each KT88 is good for about 42 watts of output. So sanely, we're shooting at 40 on the high end, right? So you might be able to get 80 watts out of a pair of them, right? 80 to 85 watts, like of raw power. Obviously, your peaks can be a little bit higher than that, and you can push them up a little bit hotter than that too if you really, really want to. The thing is that there's so much capability within those tubes that just a little bit of a push will kind of take it to the next level anyway. I'm not interested in 100-watt amps, and I kind of get not bullied, but pressured a little bit to go that way due to some friends that we all know about. If you don't, go check him out, of course. Andy Lederman, he does the big, huge amp thing. That's his thing. He does only 100 watts if he can, help it. He has done a couple 50 watters recently, though. I think more or less just out of necessity. I am not one of those types of people. I have owned many, many 100-watt amps over my life, and what I can tell you is that I've never utilized anywhere near the full amount of power that they have available to them, which to me just makes it expensive to run, expensive to maintain, and kind of just pointless to have, when you need 10 watts of power and you got a 100-watt amp, like what the hell are you doing with it, right? I kind of feel like 50 watts is kind of the end-all, be-all. There's not a whole lot of difference between 50 watts and 100 watts in terms of output and clean headroom. It's not negligible, but it is noticeable, but it's just not like night and day or make or break, right? Like the difference is pretty small. So for me, I kind of feel like 30 watts is kind of the end of the line. Like if you can't get done with what you need with 30 watts, then you probably can't. There's probably no wattage elsewise that's going to get it done for you anyway. Now, bass guitars and bass rigs and stuff like that, completely different story. And then just the way that bassists operate these days, they're not looking for the B15s anymore. I've talked about this a couple times with other individuals and stuff like that, about making a bass amp or something like that. And it's just, even in a tube amp, and I'm not going to do solid state anything like that. So with a tube amp, unless you can plop out at least 300 to 600 watts, there's freaking no point, because most bassists aren't even interested in it. Mainly because they want an amp that's smaller than the piece of paper that I have in front of me, weighs 5 pounds and produces 1,000 watts. I was talking with a bassist friend of mine not too long ago, and he's like, I don't even mess with it unless it's over 800 watts. And he's, got a nice, he's got an Eden rig, and then he's got some, I can't remember the amp, like the bass, like pedal module that they make, like whoever the big guy is for that. He's got one of those things. Like he's all about the bass and stuff like that. I have another friend, we call him Stevie Weavy. He's a really cool cat. I think he actually used to play with the George in the, what's that funk band? Anyway, that era, I can't remember off the top of my head, excuse me. But anyway, I think he used to play with them once upon a time, but he has an Elf rig, which is a freaking, I think it does, damn near sub 10 hertz or something like that. I think it can get down to like 3 hertz or something like that. Not that there's anything he would normally be playing that'll go that low, but he can get sub harmonic frequencies going and, have all kinds of fun messing with neighbors and stuff. And he's not afraid to use it either. So the predominant point about what we're talking about today is design goals. And as you can see, we've just talked about like all kinds of different criterions and, basically goals for amplifiers and what you need for them. In my case, this amp, kind of going backwards yet again, but this amp that we're doing, this new build series, is meant to be, for me, a modular design. So basically the preamp section doesn't change. It just graphs into the output section at that point. And then I can pick my output section. But what I'm trying to do is find a format in which all the holes are the same. So it doesn't matter whether I use a 50-watt transformer or a 100-watt transformer. Like, the whole pattern is basically the same. And the power transformer, well, the power transformer obviously has to be different in order to manage both topologies or whatnot. It does need to fit within the same frame, at least ideally. It's more or less, I'm thinking like, okay, if I have this, I don't have to change anything except for the transformers. I don't have to drill different holes and stuff like that. That's the goal. Now, that's, from the build it standpoint, that's future proofing myself. That's me thinking ahead, 5 or 10 steps, right? But what do you actually do when you're trying to design the thing? So there's all kinds of different things that you can factor into it that, I guess kind of play into how this amp is going to work at one thing and then yet still act the same at another, but have twice the, not really twice, but, twice the wattage at least anyway. So there are different things you can do with the output transformer, and that's kind of the heart of any amp, to be honest. It's not really the output transformer. The output transformer does have a pretty large effect. But I would say if an output transformer is designed properly and you're applying it to your project properly, it's not really going to be that big of an effect as you think it is, right? Like, if you buy 5 different transformers that all are meant to do basically the same thing, they're all basically the same primary resistance, they all basically have the same wattage capability, et cetera, like, there's nothing crazy from one to the other that's that different, they're going to sound relatively close. Are they going to sound different? Yes. Is one going to sound absolutely like doo-doo and the other one over here going to sound like God's gift to transformers? I don't think it's going to be that stark of a difference, but there will be a difference, and that difference will be subjective in terms of what it actually, what your impression of how it sounds and reacts and whatnot like that is. My experience is it doesn't matter if you use the $18, transformer from China or the $120 transformer from Hammond or Hayboer. They're pretty close. Mercury Magnetics. Hey, what's going on, dude? It's, the difference between them sound-wise is not that drastic, but it is something to consider because cheap parts, as Windsor has pointed out here, obviously don't do you any good. So, Mercury Magnetics will lead you to believe that they're the best of the best of the best, and they're going to charge you as if they're the best of the best of the best. I think they're definitely the best looking and probably perhaps maybe better made in terms of just their construction process and stuff like that. How they sound, I haven't heard any yet that make me go, I have to have that one. Like, I don't care if it costs 3 times as much, I have to have it. I have not had that experience with them. So there's always that kind of aspect to it. But when it comes to the power transformer, that is the part that really can make or break your amplifier. It really kind of involves a lot more math, probably, than most people are willing to put in. But you kind of have to know your tubes. You have to know what tubes you're going to go with, and you have to know what they're going to pull. And there's calculators online. They kind of tell you. Most of the sheets now kind of show you what, like, a pair of KT88s and a push-pull amp will pull. And it gives you a rough idea. It's not an exact number, but at those operating conditions that they set, that's what it will pull. Generally speaking, most pairs of tubes don't breach over 150 milliamps in general. Now, that's not a hard rule, but you can safely assume that if you have a pair of any set of tubes, 140 milliamps is kind of the max that they're going to run at. And then do some more math with your preamp stuff. If you've got 4 preamp tubes, including the phase inverter. So you got 3 preamp and your phase inverter. That's 4 tubes. Factor in 2 milliamps a piece. 1 milliamp for each triode in each of the tubes, right? So there you got 8 triodes. So 8 times 1. You got, 2, 4, 6, 8, right? 8 milliamps. Round it up. Give yourself a safety margin. Make it 10, make it 15, whatever. You're still only at 150, 160 something milliamps worth of total current draw. So you're going to go out, you're going to find a power transformer that says it produces 100, X wattage at 170 milliamps. And you're thinking, that's perfect, except for it's not. So you want to have a safety margin. How much? That just depends on how you want your amp to run. It is a real show now. So a power transformer has like a D rating, I guess, if you will, or a, what do they call it? Like an efficiency rating. And usually they're rated at right around 4 to 5%, which is to say that at the load that they're rated for, they're going to drop or reduce in voltage by X amount. 5% is usually that number. So if you have a 100 milliamp output or power transformer, and you put 100 milliamps of draw on it, you're probably going to drop 95% of that volt or 5% of that voltage off the top at whatever voltage you are, right? So if you had it just easy numbers, if it was a 100 volt power transformer, you'd drop down to 95 volts. So that kind of gives you an idea. Obviously, the higher the number is, so 500 watts, you take that 5% off of there, and you can see how that adds up really quick. So you want to try, and Windsor's kind of beaten to the punch on what I'm talking about here. Yes, you want to exceed the power transformer. You want your power transformer, to exceed your needs by at least a 50% margin. So that's to say, if you know that you're going to be pulling 100 milliamps of current, you better have at least 150 milliamps available, if not more. I would say probably more. I like right around 80% myself. That way you know that you're in a good spot. Like, it's not going to derate down too much. I know you're laughing now. But you're not in that weird spot where you can't guesstimate what's going to happen. Or you can do, no, it's all good, dude. Or you can do what I do, which is just go off the freaking deep end. In this particular build, I'm probably going to have a transformer that's 3x the amount at least that I need. I'm using a 575 milliamp power transformer. Even with the KT88s at full roar, it would probably only draw maybe 170, just round it up to 200 milliamps. And I still have 300 milliamps more to go. My rough math derates the power transformer down like 1 to 2% or something like that. Like, more or less, the power transformer won't even know that the tubes are there. Very, very stout, very, very stiff. It will not sag. It will not drop in voltage, etc., etc. So again, there's a reason for that, and that's because I wanted a stiff, firm, and readily, punchy output section. That's more or less. The output section in this amp is meant to just simply reproduce whatever the preamp is doing. There will be no power amp distortion in this design, which is why we're kind of talking a little bit about what it is I was doing and why it is that I changed course. So going back to Andy a little bit about him bashing on me for using KT88s, I kind of crunched some more numbers. And I was shooting for at least a good 30 to 40 watts of just pure, clean output power. No distortion whatsoever. Like a solid, I was shooting for right around 35 watts. Just round it up there. 35 watts of absolutely clean power. The last, few watts, 15 watts or so that you're going to maybe utilize might have some power section distortion, but I doubt you'd want to be in the room with it at that point in time. But then I kind of like, well, that is kind of a waste of these KT88s. That's about what they would produce, 32 to 38, watts of clean, actual clean power. And I was like, yeah, that's close. That's about what I wanted, but let's see if I can do better. So that was my thing, was like, what can I do that's better with the same thing that I have going on here? Hey, Short Circuit, how's it going there? So I started crunching the numbers, going through with this transformer and with this, with the two transformers that I have. And I was able to figure out that a KT77 would actually net me 50 watts of clean power. Straight up 45 to 50 watts of absolute clean power. No distortion, etc., yada, yada, yada. So the last 5 watts of power that the amp even has available to put out might be distortion. Again, if you were in the room at the time that that's going on, I highly doubt you'd want to be there. And it would be extremely firm because, again, KT77s don't draw quite as much current as a KT88 does. Now, why does a KT77 seem to do so well versus that of, say, like an EL34 or a 6L6, 5881, KT66, etc., etc.? Well, it has to do with how those tubes operate. And they all kind of do the same thing, but they do it just a little bit different. Some of them are pentodes, some of them are tetrodes, etc., etc. KT stands for kinkless tetrode, right? So kinkless being that there's some part of the knee that they were able to not get out of that design by going to a tetrode, whereas the pentodes kind of do it a little bit differently. 6L6s are a little interesting in that their screen is a little weak, if you will. So it's just not the most robust screen. So they really, really like the screens to be under control. They kind of don't really like a whole heck of a lot of cathode current being drawn through them. Doing that kind of upsets the tube a little bit. The more cathode current you pull, generally the more abuse you have on the screen itself as well, which kind of doesn't bode well for some of my designs because I try to induce more cathode current in my designs. That is a design goal that we're kind of talking about here. So, an EL34 would produce roughly the same clean power as the KT77, but it's not as happy with the output transformer primary that I was shooting for, right? So I just went through every tube and kind of did all the math and worked it all out, yada, 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 et cetera, et cetera. Landed on the KT77s. KT77s with the voltage I intend to hit them with, so somewhere between 410 and 420 is probably what I'll end up with. Shooting for a solid 410. Again, my power transformer is not even going to know that tube's there. Like, it's going to turn on and it's going to be like, da-da-da, it's just going to cruise. So whatever my rectified voltage is, it's not going to drop much, if anything at all. I'm expecting at least 424 volts to 430 volts after rectification, and I imagine I'll end up closer to 410 after this thing is all done and up and running and stuff like that with the KT77s. With the Para KT77s, I suspect I'll only pull about 130 to 140 milliamps. And then again, with the preamps, probably going to end up with 5 or 6 tubes. One of them, I'm still going to use the 12AT7 for the Pi, which will push the KT77s to clean the whole way. So the Pi will not distort while producing all the power it needs to run the KT77s full bore. Imagine that. So the output section will be absolutely clean for a solid 45 at least watts to 50 watts. I suspect I'll end up with 60 to 70 watts peak power. So, you turn the amp all the way up and give it the ka-tunk, the chug-a-chug with an 8-string or something like that. And yeah, you might be telling that output transformer to get with it. I don't think it would do that for very long. I don't think you'd want to be in the room that very long if it did. That's just my guess. So, the point of what, again, we're talking about is, of course, amp design and goals. So, obviously, we're going for a very modern, very tight, very stern, authoritative, punchy, whatever kind of expletive you want to use to describe the output section. As far as the preamp goes, I haven't quite settled on where I'm going to go with that yet, but the preamp obviously is meant to be high gain. So yeah, it's going to be pretty mean. I'm kind of shooting more towards diesel territory. I kind of like the smoothness of it a little bit more. It's not as rude, I guess, maybe, as like a 5150. I had a 5150. I also had a 6505, and I got rid of them both. All right. Whereas I currently own a PV Triple X. I just kind of want to call it the JSX because the Triple X is just kind of dumb, but and I like it just because it's a little bit smoother. It's kind of got a nice rip to it, is what I call it. It's not a very heavy, chuggy kind of amp, so I'm kind of shooting for something in between those, but just with a little more soul, I guess. The Triple X I have, I don't know if there's something going on with it or not. It doesn't have a whole hell of a lot of balls to it. To me, it always kind of sounded a little too thin for my liking. And I got it with the actual cabinet that it's supposed to come with as well. And it did what it was supposed to do for me at the time, but I was never happy with it. The only reason I kept it is because it was a really nice, of all the multi-channel amps that I have, it's probably one of the better multi-channel amps I have. It has a real clean channel, and between the two lead channels or gain channels or whatever you want to call them, you can get somewhere with it. So, whatever. But you might not want a modern amp, and you might want to derate your power transformer a little bit to try to induce some sag, or maybe you can't find the exact voltage that you want. Like maybe that 650 volt power transformer you have is a little too stiff for what you're trying to go with, but you can get one that's a little bit lower in milliamp rating. So, going again to the 100 milliamp versus 200 milliamp versus 500 milliamp. So let's say you need, a solid 150, 160 milliamps of, of power transformer. Well, you can get the 200 milliamp power transformer. It will run a little bit hotter. It might not burn up though. It'll just run a little bit hotter. But because you're so close to its edge, right? You're right about that 50% safety margin in that point. It'll sag down a little bit more at operating, at its operating point, bringing that voltage perhaps to where you want it to. And it will induce a little bit of sag. It'll, compress and give a little bit. So that's something you might consider if that's what you're looking for. Another thing to consider too is just, I guess when it comes to power transformer, that's really the only thing you care about. Where is it going to sit, and, what level of derating are you going to have on it? But that is one of those things. Do you want it to be vintage, where it's a little bit closer to the ragged edge, or do you want it to be modern, where it's way overrated and it has more, it's stouter than it needs to be to do the same job? Other things that come into consideration, of course, is how versatile you want the amp to be. So in this case here, we're going to have an amp that can pretty much run any of the octal tubes. It's going to be designed to, it'll run KT88s. It has no problem doing that. It can do it all day. But it's going to be designed, in fact, to run KT77. So let's just do that right now, and we're going to put 77s, right? So now we know it's going to be designed for that. But can you put an EL34 in it? Certainly. Can you put a 5881 in it? Probably. You probably wouldn't want to, but you can do it. It's a little too stout for a 5881. 6L6, yes, it will do that. And just about any, like a 6CA6, I think it'll do just fine. KT66, it'll do just fine, etc., etc. Little things like that will kind of get it in there, but it's meant to run basically a multitude of tubes, or you can. So you kind of also have to take that into consideration too, is like, what is the end user going to do to the darn thing? Are they going to be silly and try to put a 6V6 in the thing? I tell you right now, if you try to use a 6V6 in this amp, it's not going to last very long. At 420 solid volts, I imagine the tube will just, it's not really meant to work at 400 plus volts. Even though some people do it, it's not really meant to. So I don't feel that it would last very long if you were to have done that. Also, let's say you put a 6L6 in there. The way I'm doing this, because it is lower voltage than most people run, again, that's a thing I like to do. It's kind of a thing it's something I do. It's a little bit different than what everyone else is doing. That induces more cathode current, and with more cathode current, you have to be more stern about your screen grid. You need to make sure that your screen grid voltage is at or below a certain point and that it doesn't creep up. And you also have to manage or watch, track, and see what your screen grid is pulling. More or less, you do that by measuring over the top of the screen grid resistor. And then you measure that voltage drop. With that voltage drop and the value of that resistor, you do the math on that and you can figure out what your draw is or what wattage you're pulling through that resistor. And with that, you can determine whether or not you're over dissipating the screen grids. Generally, you can kind of tell right away because if you turn out all the lights in the room and give it the Kerrang, turn the amp all the way up and give it the beans, you'll know right away because you'll see the screen grids start to actually glow. And it's pretty obvious when they start to glow. Instead of a blue glow, the blue glow will kind of go away. It'll sink away as the voltage dumps, out of the system, or depletes, I guess, if you will. But then you'll see like kind of this orange glow come up, and that orange glow that you see coming up is the screen grids actually starting to glow. That is not good, because you have to imagine they are not meant to glow. And like any light bulb where the element is, on and burning as bright as the sun for X number of time, it has a limited lifespan. And when the screen grids go, heaven forbid they don't, break and then touch one of the other grids nearby, because that would be very ungood. And that's when output transformers and tubes go into thermal, nuclear meltdown in very short order, which is why they kind of use resistors in the, on the screen grid as a fuse, if you will. You get a resistor that's lower rated than what your screens can pull. And the hope is that by the time you pull that amount of wattage through that resistor, the resistor goes opening up your screen grids. And then that, of course, saves your screen grids from going into thermal meltdown. And your amp will obviously be very upset with that. It won't work right. It'll sound off, and it won't do what it's supposed to do. Yada, yada, yada. Yes, it does big time. So you got to remember, it's all about Ohm's law with everything. So the more voltage you run on the plates, the less cathode current you're going to draw, right? So generally running with more volts on the plate means you end up with more leeway on the screen grid, right? It's easier on the screen grid. But you're still running more volts on the plate, and the plate is where all that heat is dissipated through. And the more heat that the more voltage, the more heat, yada, yada. Even if it's within safe dissipation, it's still going to have a propensity to, burn out sooner. It's like a light bulb. If you use it, you will lose it, period. I know that there is a light bulb that's in a fire station that's been running for the last 100 years. That's an oddball. That's not what these things are. That's why I've never been a big fan of like the whole, NOS tube thing. Or, it's a light bulb. It is going to go bad, period. It doesn't matter. If you use it, you will lose it, period. So why are you going to spend $100 on this thing that you really don't want to use anymore? Because if you use it, you're going to lose it. It carries no value anymore. The whole NOS thing is just it's a ruse. Now there's scams out there. There's literally people finding ways to rebrand modern tubes and make them look like they were old stuff, and Lord knows what. And I dare say that all of the really, really good tubes, the ones that you actually want, the ones that stood the test of time, actually have already been picked through and sold to somebody else who's put it in their freaking piece of shit amp that they stuffed in their room and said it's the best it's ever been because it's an NOS tube. And, the last 10 years they've been using this amp, and it's worked, but, like anything, eventually that bulb is going to burn out. So, it affects load line, headroom, etc., etc. Yes. To a degree, though, I mean, it's still based on how everything works together. So, I wouldn't say that you want to, if a tube is rated for, say, 500 volts on the plate, right? And that's a safe number for most of the large bottle stuff. But, 500 volts is kind of where they put the max. So, if you put 500 volts on the plate, sure, it's going to last. I mean, it's going to work anyway. It might not burn up today, but maybe 2-3 years from now under regular use, yeah, it's going to burn up. But if you put 400 volts on the plate, could you make an argument that it would last longer with minimal compromise in the quality of sound and whatnot, right? You can still get the 100 watts out of it. You're just shifting the onus from the plate to the cathode. That's all you're doing, is shifting the onus from one side to the other. It does kind of change how it works as the load lines kind of, stack up on that. But is it, I guess that's the compromise, right? Which one do you want? And do you necessarily want it to always be at the, the bleeding edge? Maybe you actually want it to dig into the screen grids a little bit more. Maybe you want a little more cathode current to get some earlier breakup, etc., etc. So generally, the more cathode current you get, the tubes will have a propensity to break up a little bit sooner, which I guess in a 100-watt amp isn't saying a whole heck of a lot, right? Because it's not very often people are actually driving that amp loud enough to get any output section distortion. And dare I say that most modern high-gain amps are probably beating up on the plates anyway. Yeah. The headroom harmonics. Yeah. No, it's all true. I shoot for right around the 2/3. I kind of think that's where I land most of the time. I kind of feel right in there. I try to lean close to 50-50, but erring to the other side. So the lower the voltage you go on the plates, the more cathode current you pull, which is why I generally, if I'm pulling something like that, I'll use a higher than is normally rated primary resistance for that particular amp, because that does ease some of the it eases some of the onus off of the screen grid a little bit more. It does change how the tube in and of itself operates. Again, those load lines and stuff. But that's, I said I have a thing that I do. And I've said it before, I like lower than normal voltages with higher than normal primary impedances. And because of that, it's partly to save the screen grid a little bit, change where it operates at a little bit, while still producing X amount of power, yada, 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 XYZ. Of course, I'm not going for high wattage amps in most of my stuff either. So while I'll have an amp with a pair of EL34s in it, it might only be producing 30 watts, right? That sort of thing. It's kind of a train wreck thing too. While most people would want to believe that his Trainwreck Express or whatnot was like a 50-watt amp, it wasn't a 50-watt amp when you were running it at the lower voltage that he had. And I'll bet, I'll bet that most people probably liked it at that lower voltage. I'm not saying that's the case, but I would bet. Let's see here. Yeah, plate to cathode. But it depends, because you can play the game a little bit more too with a cathode biased amp. So with a cathode biased amp, yeah, it's plate to cathode. But it is technically in a fixed bias design plate to ground in a sense, right? There's 100 different ways you can do it. And obviously, shifting something 10 volts this way and getting a slightly different output transformer can, change things all kinds over the place. Which one's the better? I don't know. That's for the ears. What do they say? Like beauty is in the eye of the beholder. It's kind of the same for ears. Everybody hears things a little bit differently. Right? It's subjective, I guess, if you will. And what I might like, someone else certainly won't. But that's, I don't know how else to explain that one. I don't think they're that set in stone, though. Like most of the linear range for a tube is where you're going to be working with it, right? For this, talking more about the output section. Even if you design your amp so you get early, power tube breakup, I mean, how loud do most people play their amp? I mean, especially these days where most venues want you to stay within a certain dB limit, et cetera, et cetera. Unless you're like Joe Bonamassa and you can literally have all your amps running at 10 the whole time, right? There's not too many. It's a 1%er problem, I guess, when you get to that level. I'm not necessarily trying to build an amp to eke every single watt out of it. I'm trying to build an amp that sounds a particular way and is versatile. So it gets loud enough at clean levels to be pleasant and do what it needs to do at clean levels, within reason, of course, given its wattage. An 18-watt amp, I'm not going to expect it to be absolutely 100% clean while it's dimed all the way up and still be clean over that of a drummer. Now, I would expect a 30-watt to get freaking really, really, really close to that. Like, if you got a drummer hammering away, it should stay pretty dang clean, more than loud enough to deal with it. should. That's not to say that it will, but, and then of course, if you really, really want, some people, they like running with 5-watt amps in those types of situations because they don't ever play clean and they just want that crunch. So a 5-watt amp, the one that I have anyway, the one I designed, it kept up in the two bands that it was being utilized in for several times. Obviously, the players did not play clean, but it kept up with the drummer well enough. Yeah, right. 2 to 4, at least. That's why I never gelled with the 100-watt amps. It's like literally you crack the volume up and you're just like, man, I'm already getting blown out of the room. I've already got the freaking venue, owner. Yeah, right. The venue owner's already saying, turn it the fuck down and this, that, and the other. You take it to any other stage, and by the time you get it that loud, the freaking sound guy's yelling at you. And as a sound guy myself, like there's a limit to how loud you can go before it's out of line. Like you can be pretty dang loud. It's like obviously guitars kind of need to be a little bit on top of the drums and all the other stuff, but when I've got everything mic'd up and I can literally turn you off and I still have to turn everything else up, drums included, then obviously there's a problem. In smaller venues, I used to do a lot of small venues, and it took me a little while to kind of understand like the dynamics between front of house sound and backline sound. I'll get into that in just a second. But it took me a little bit to realize like the band itself makes up probably in a smaller to medium-sized venue, probably makes up 50% at least in a smaller venue to 75%. In a medium-sized venue, maybe like a 300 cap building or something like that, maybe 50% to 25%. Like whatever the band is doing is going to affect the front of house sound by that much, right? So average it out 50-50. I have to compensate for 50% of what I do, I can't change, more or less, right? Or 50% of what is heard, I can't change, that sort of deal, because it's driven or delegated by the band and the backline equipment itself. Crossline, I do not like. I am not a crossline master volume guy, and I am not a Larmar guy either. So in cathode biased amps, I find it just fine to use, a normal, you use a dual pot, of course, but you treat each send going to the power tubes as its own little volume control, right? No biggie. I just make sure that my droppers, or whatever you want to call them, the grid leaks, are after the pot, right? So that way, if the pot ever does go open, the grid leaks are still there, and the output tubes don't try to burn themselves up. That is cathode bias. Now in fixed bias, I have it's not Frommel. I can't remember the damn name of it, but it's a variation that's similar to just what I was explaining, but you still use a dual pot, but you feed the bias through it, right? So the bias supply is what actually makes the ground of that pot, and then you run the other two the same, right? So you got each side from the phase inverter coming in, and then the other two still go out, but the bias itself is tied into that pot, so it's always referenced to it. So more or less, when you turn the volume down, it's shunting it into the bias supply. That's kind of, I'm glad you can finally make it too. I know you're quite a ways away, so it's nice to see you. I'm glad you can make it. Thank you for hanging out with us too. So no, I do not like the Larmar. The idea of using it just doesn't work that well. The best, fixed bias post phase inverter master volume that I have come across is that, I wish I could freaking remember the name, but it's like Frommel or something like that. I think it starts with an F in either way. But the bias supply feeds through the pot, and you basically are referencing the volume control to the bias supply. So you're not actually like turning down the volume by dumping it away to ground. You're dumping the signal into the bias supply. So that way, if the pot ever does go open, so the center wiper, if it ever goes open, the bias supply is still fed into the circuit, so you don't lose bias, more or less. And I find that it doesn't really affect the volume all that, or not the volume, the sound all that much. It's pretty clean in terms of, Former. I can't recall. It's not Former. It's like Frommel or something like that. Something like that. Yeah, I could be wrong. I'm trying to. It's literally off the top of my head. I know it starts with an F though, or something like that. They actually have it on the gear page, and I can't think of any other way to explain it. I was talking about it recently with someone else, but it's something like that, and you'll know when you see it because the bias supply will feed into one of the lugs of the pot, and then it kind of works like normal after that. So it's nice though because the way it works, if the wiper ever, it can't because the way it's set up, I think it works in reverse actually. What it is that the phase inverter goes into the wiper, and then the actual output goes on the other side of the pot. So the bias supply on one side and the send going actually into the grids of the power tubes is on a resistive track that never breaks, right? Well, in theory, should never break. They're nice. Getting kind of back to post-phase inverter versus pre-phase inverter. Again, this is kind of another design characteristic that you have to decide for. Andy is a big fan of just using a pre-phase master volume. His whole idea is that, the pre-phase master volume does everything you need it to do, and the amp works just like it's supposed to all the time. So why would you ever use a post-phase master volume? I think he kind of just doesn't understand that some people like getting phase inverter distortion. And in many of my amp designs, that's where most of the distortion actually comes from, is from the phase inverter. And it does have a sound, and it does affect things. I think the sound that most people like about like a JCM 800 isn't the preamp distortion in and of itself. It has to do with when you get it dimed up enough that the phase inverter actually starts interacting and getting its own level of distortion. I think it's something like that. I could be wrong. I'd have to look it up. Maybe I can do that real quick. Hold on. Maybe I have it in my drive somewhere. Excuse me while I float around my thing here. I'm going to see if I can find it. And of course, it's not going to be. Let's see if it's in my recent. Nope. Of course not. Oh, there it is. Haha, dual bias circuit. All right, so I'm going to go. Hold on here. Ah, you motherfucker. Sorry. Let me download this so that way we can just see it. We're gonna do this together, you and I. We're gonna open that up, and I'm gonna expand that out, and I'm gonna take you to my desktop. And I don't think there's any. Okay, cool. Yeah, the vocals are still working, all that fun stuff. All right, so what you're seeing here, I'm watching two different screens at the same time, so don't mind me, but you should be seeing this here. You can kind of see how it works here. So this A and this B, this is a circuit that I designed kind of in conjunction with Merlin, actually. I believe the gentleman that I worked on this with talked to Merlin about how I had a rough idea of how this would work. And then Merlin's like, I think the dude showed him like 3 different variants. The Crossline was one of them. The Larmar was one, and then this one here. And Merlin made a couple adjustments. I think he changed where this network here, I had it a little bit different, and I think that was about it. I think he just changed where those caps landed, because I think I had one on either side. It was a little different. Either way, maybe I had it over on the opposite end or something like that, but you can kind of see how it works. You got your HT comes in, and this is fed from the HT, not from like a 50 volt line. So it comes off the HT. You use the 100K as a dropper. Excuse me. Use your diode. That's what gets you your negative. And then you obviously you reservoir cap that thing. Another little dropper to smooth it out a little bit. Another reservoir, right? More smoothing. And then these here are just to keep these from interacting with each other, because this is a dual adjustable bias here, right? So let's say you don't have this and you just have one bias supply, but it's basically this principle that you see up here. If this is the bias supply, it would feed into this, et cetera, et cetera. But because of how you're doing this here, you never lose bias, but you still basically work the master volume the same way. So this would be post phase inverter, of course. So there's your pi, there's your coupling cap, et cetera, et cetera. So I was wrong. It is set up as a standard, but the way that it works is it dumps that load into the bias supply. In this case here, it's dual adjustable bias with still, that dual gang pot. So this is a dual gang pot here, right? And then these are just your normal bias adjusting pots that you would have. And I think this is the finished one. I could be wrong. I don't know if this was the finished one or not, but more or less you use this one to kind of set your high voltage. Well, both of these here to set your high voltage. So if you want, minus 70 volts, you get it to its minus 70. And then this one here, you use to adjust your minimum voltage. So if you don't want it to go below minus 30 volts, you set this up, so, higher or lower, so that way your minimum voltage, works between that range. Again, these ones here are just to make it so that they don't interact with each other. So if you adjust this pot a little bit to make this tube warmer or colder, or whatever you need to do, it doesn't affect this one as much. I can't remember what he did, but this is a circuit that I basically designed and have not used yet. So someone else proofed it for me. It does work. So there's that. So I try to do some clever stuff, but that's just another design criterion that you have to decide. Do you want post-phase inverter master volume? I like it because I like being able to, I like having both in the same amp. And it's just because if you do want to get the full experience, of an amp that's kind of cranked all the way up, you really have to have the phase inverter involved, which means you have to have a post-phase inverter master volume. Some people like it, some people don't. This particular amp design I'm working on here will not have a post-phase inverter master volume. The phase inverter will not be set up to distort. It should run clean the whole time. I am going to have an effects loop. Yeah, no, I'm always glad to help. So, I can't remember what it was. I think the day that circuit was created, it was Riley. Yeah, I'm sure you've seen it before on some of these other channels. I think he's been here before too, but Riley is his name anyway. But he was like, hey man, I'm trying to do this and I want to do this. And Andy was kind of just not getting it. Like, why would you want to do that? Like, knock it off. Just do it like this. And he's like, no, you don't understand. He wants to have a post-phase inverter master volume. Well, why the hell do you want to do that? You're doing it wrong. Just do it like this. It was kind of one of those funny things. But Riley and I kind of got on the same level. And I literally was running on 2 hours of sleep. And I was just like, okay, hold on. Give me a second. I can wrap my head around this. I know what's going on. Here's what I would do. And I missed it by that much. Luckily, Merlin was around to kind of help pull it all together. Again, he just more or less changed the filtering a little bit more. But and I think he added that other resistor or something like that to make it so they were less interactive. Something along those lines. But either way, two minds are greater than one. So it worked out great in that regard. LARMAR causes too many issues, and trying to use a 2.2 meg or something like that to make sure the bias doesn't shut off when you roll the volume all the way down is just pointless to me. And they don't sound all that great. The Crossline, Matchless is famous for doing that, and of course Bad Cat as well, because they are basically matchless amps. I think with those designs, they're great, right? So like chimey, kind of that sound. Which Matchless is kind of known for that more chimier sort of thing with their DC30s, et cetera, their Chieftain and whatnot. So when you have the master volume turned down quite a bit, it does kind of brighten the amp up, and it has to do with how it interacts with the coupling caps. Because you have to put that cross line after the coupling caps, and I don't know what it is that it does. It's so weird, but it just causes it to get brighter, and I think it's just because of the effective, what would you call it? Like corner frequency in relation to this the grid leaks that are on the grids of the tube. It interacts in such a way where it kind of has that effect where it just lowers the knee or raises the knee. Those are other considerations too that you can think about. We haven't really gotten into coupling cap versus grid leak sizes yet to calculate like your corner frequencies and stuff. Same rules apply in the power section. Going with really, really large coupling caps in the output section are great because you get a lot of thunderous lows and all that fun stuff, but it's also more prone to blocking distortion because once those caps charge up, it takes a little bit longer for them to discharge as well. And that's what causes the blocking distortion when you start getting into grid conduction in the power tubes. So that's not good. So going with a smaller CMR, common mode rejection or something like that. Something like that is what I'm guessing. That's the only thing I can associate it to, is that when one side is going one direction, one side's going the other way. So it's kind of like sharing, because it's almost shunting them together, right? So you're kind of taking the two grid leaks that are already touching together in the same spot. I kind of feel like what it's doing is lowering the effective value of those because it's kind of running in parallel, if you will. You get what I mean? So it's like basically taking another pair of them and putting them together in a sense. Even though those ones go to ground, these ones are effectively going across. But that's kind of what I think is happening to some degree. And yeah, it changes the corner frequency. I could be wrong though. That's just my impression of what it's doing. But generally going with smaller, if you can go with smaller coupling caps, it's generally better, especially in the output section, because it'll be less prone to grid blocking. But that means you have to use larger grid leaks, which is generally a problem with some of the larger tubes. Again, excuse me. I got the Dr. Pepper burps today. Woohoo! So with the larger tubes, most of them don't or can't have more than, I think KT88s are rated for like 100 ohm or 100 kilo ohms of grid leak. And, most amps are punching up there at like 220 K or something like that. Tubes seem to deal with it, and it's just mainly because you got a bias voltage that you can keep it in the safe range with. But they put those limitations there for a reason. Most people tend to break them, and that's kind of how some of these amps came to be. Marshall's probably one of the more predominant ones to have done it at one point in time. I think they were using, well over 100% of what they were supposed to have for grid leak or grid reference off the power tubes. Again, it's something you can do, but it's not advisable. So, hold on, I got the wife. Okay. She's texting me. She bought something. Darn it. So yeah, there's all kinds of like little things like that, but getting kind of, I guess, into design criterion, again, that's something else you're going to have to figure out or decide on. Like, where do you want the bass in your system to come from? The more bass you have earlier in the stages, the preamp stages, the more flubby it'll kind of get. So you kind of got to knock things down here and there and keep it balanced, I guess, if you will. But when it comes to the output section, if you want to have 20 to 20 kind of frequency response, you have to kind of keep in mind what's going to happen, which is why the 12AT7 has come into play. So with a 12AT7, it will allow me to run a 0.1 coupling cap without worrying of getting charged up, all right? Because the 12AT7 produces enough current to drive the power tubes without the grid itself getting, conducting. It's when grid conduction happens that it starts to charge up those capacitors. Because remember, they're supposed to be negative in reference. That essentially, that's kind of what so if you go back earlier in that segment where I showed that little circuit, that's essentially what this is. It's using, not negative feedback. There's a danger to that. I'll talk about that in a second, but that's kind of what it's doing. It's using a negative voltage to basically take volume away, right? That's essentially what it's doing, is shunting it out. But with negative feedback, it might work in the preamp stages. In the power amp section, not so much. Here's why. Stability. Because there's always a phase loop that goes on. Anytime you go through a coupling cap and a resistive network, right, which you have to have a coupling cap to get from one stage back into another, right? Because you have to have that. So when you do that, you end up with this open loop gain or closed loop gain or whatever you want to call it. But in either case, there's a phase difference that occurs, and that, at some frequencies you'll have 100%, cancellation if you get it up that high. But once you get out of that phase realm, it's going to start to oscillate. And when it oscillates, it'll just go into squealing chaos. And it can also get into the ultrasonics, or subsonics, so areas you can't hear. And it can cause the tube to basically burn up. It goes napalm death, and you don't know why, because you can't hear it. So negative feedback circuits are kind of tricky. Once you get above like 10 or 12 dB of effective NFB, you're getting into the danger zone. That's where squealing, oscillation, and other things like that can kind of instability. That's really what it kind of happens, is that the feedback loop goes open due to the phase differences, and things go chaotic. So yes, not ideal. Okay, closed loop is NFB. That's right. That makes sense. Closed loop. I knew what I meant. You knew what I meant. I think what you have to do is figure out what your open loop gain is in order to understand what your closed loop gain is. And then, of course, you do the 20 log. There's math to it. But you take your 10 log or 20 log or whatever, and that's where you come up with the dB reduction that you would get. I'm not a fan of negative feedback. I will have negative feedback in this amp, but it's not going to have, what would you call it? It's not going to have presence, and it's not going to have depth or anything like that. It's going to be more like a variable amount of negative feedback. So you can have it so it has very little for a more open, just a more open and less compressed feel, a little more volume. Or you can dial it back to kind of tame it down a little bit and tamp it. So you'll have a little bit of what kind of feels like compression or choking it up a little bit, if you will. But it'll also even out the frequency response a little bit. It'll generally get a little bit flatter, more linear. I kind of feel more people will tend to go for flatter, more linear. But if you want it to kind of act more like a cathode, well, what most people attribute a cathode bias amp to work like, by rolling it up the other way so it's open and loose, we'll kind of do that. The PV-XXX kind of has a circuit like that. If you've ever seen the original ones, they had a three-way switch in the back, and it was loose, medium, and then tight. That's all it was just three settings for the negative feedback in it. I think loose was wide open or something like that. And you probably noticed that when you switched it over to tight, it lost a little bit of volume, but it did get a little bit thinner sounding and a little bit it closed in a little bit, right? Even though that's not what it's actually doing. It's just that the humps are getting taken out, so it's flattened out a little bit more. But that's all that was doing. It was just negative feedback that was variable. Clean or dirty, yeah. You can make it variable. You can put it on a three-way switch. You can do it all kinds of different ways. It's just an amount that's fed back. You can change the tap so let's say it's normally on the 4 ohm tap or something like that. If you want a little bit more negative feedback, you can put it on the 8 ohm tap, and you'll notice it right away. By the time you get it over to the 16 ohm tap, you're probably going to have too much. But yeah. Bypass caps, yeah. There's a lot. There's more to it than meets the eye, because you can make it so it's frequency dependent. One of the tricks that Friedman does for some of their amps, so in the original Marshall designs, they use like a 0.1 UF for their present circuit. which is essentially, it's kind of the inverse of what you think it is. So a presence pot works in reverse to what you think it's doing. So when you're churning it up, it's getting brighter, right? It's adding presence. Well, what you're actually doing is reducing the amount of highs that get into the loop, which means that they're no longer in control in that loop, so they go through unfettered. So when you're churning the pot up, you're actually churning the highs down in the loop. So it works in reverse. Well, imagine doing the same thing with the low frequency content, the depth control. That's all you're doing is dumping low frequency out of the loop so that the amp can then amplify them like normal. Yeah, that's the hard part. I would agree. That's probably, I don't like using too wide of a sweep, because then you end up with a spot where it just kind of does nothing, and then it jumps up. And then if you go with too low a value of a pot, yeah, you end up with this small range. I'm looking for kind of a small range. I'm trying to get something that'll go from basically no or very little negative feedback to just around 10 dB. I think beyond that, it's going to be too much. But I don't know. That's going to be one of those things I'm going to have to experiment with it. I think 100K pot will do it for me. And then I'll have, a tail, if you will, on the pot to keep it from going all the way full open or whatnot. So feedback is a weird one. I don't like it, but you can also use it in the preamp section. It does kind of the same thing in the preamp. Dumble kind of has a couple circuits that do it. I think his Tweedledee uses it in one spot. The PV 5150 and 6505 actually does it in one of their amps, or in that amp, I should say. There's a couple different amps that utilize that. Some of the ODSs, I think, had it as well. And you've seen it before as like a 22 meg with like a cap in front of it. 22 meg, I don't know what he was actually doing with it. By the time you get that high up in value, it's not really doing all that much. I think he just kind of did it to fool people a little bit, because I played with it. If you use 1 meg, it's way too much, right? It really chokes things back. If you use 5 meg, it's probably right about spot on for most people. When you double it up to 10 meg, you barely even notice that anything's changed when you like switch it in and out. So you can only imagine by the time you get to 20 meg, like it's not really doing anything, if anything, at all, even if you make it frequency dependent. And then maybe the only thing he was doing with it was that maybe he had some really high frequency oscillation and he just needed to get just enough of that out. And that's might be all he's doing. I hate getting into like the reverse log and all those weird tapers. I'll probably have to use reverse log to get it to feel right, but I might just go linear in hopes that because of the way that circuit will work, that it will just be kind of a linear sweep. That's the hope, anyway. We'll see. I have to play with that one. Hey, Lefty, how's it going, dude? I can't say that the phase inverter really does much for it. It's closed loop gain, right? So the phase inverter, the signal goes out of the phase inverter into the power tubes, and then you're taking the tap from one of the output transformer leads. So the 4, 8, or 16 ohm tap, one of those three, right? And then you're feeding it back around into the tail of the phase inverter. And there's usually a network down there. There's 2 resistors, right? One's the actual tail for the phase inverter itself, and then the bottom one is just the tail for the injection point, right? It's what allows the difference to exist for the feedback to feed into that circuit. So it really doesn't have much to do with the phase inverter itself as much as designing that closed loop gain. I'm letting you guys chat a little bit. I'm going to take another sip here. I was just in that general vicinity not too long ago. Not Minnesota / Oklahoma, Arkansas, etc. But I was in Tennessee a few weeks ago. It was really pretty over there. Is it hot still over there now? Probably imagine it's a little bit hotter now than it was when I was there, but it was like 90s when I was there and like 80% humidity. It was fun. I don't know what it is about Arkansas. I've been getting a lot of things lately about Arkansas and buying houses and stuff. I've been interested in buying houses, and I live in California, so anything outside of California is like freaking cheap to me. But it's just not practical. Like I've got kind of one of those career choices. I guess I could move across the country, but I'm in a pretty good spot right now, so I'm not into it. Yeah, more or less. It doesn't matter what you put in there. It's gonna what goes out. It's gonna kind of get spit back into it at some ratio. So it's same. I'm not a fan of negative feedback in general, just because of the way it works. I understand that you need it to linearize things. So when I say linearize, I'm talking about frequency response. So for those that are uninitiated, let's say the natural frequency response, if I can get this pin to work, there we go, is something like this, right? Well, you got a peak up here, you got a peak there, and you got a peak there, et cetera, et cetera. And you want something that kind of looks more like that. Well, when you take this peak and you squeeze it down due to negative feedback, and you take that peak and you squeeze it down due to negative feedback, and you take that peak and squeeze it down due to negative feedback, when you raise the volume back up to make up for that difference in loss that you have in all these other spots, right? Well, what it does is it linearizes, right? So it's now flatter, and it kind of has the effect of increasing the bandwidth, if you will, because now you've got just this much more low coming up and just this much more high coming up at the same level. But you're also taking everything down here. So let's say this is all noise down here, right? Let's say that's the noise floor. So a lot of noise. Well, when you have to raise the volume to make up for what it cut out of the circuit or with the circuit, you're taking that noise and bringing it up with it, right? I would have to say the hi-fi guys are a little more technical, I guess. I don't know. Like I like the idea of the hi-fi thing. I get it. You have to have it, especially in an amp that's meant to produce things at linear whatever. But it comes at a cost. A is that noise that we were talking about. B is that there is a reduction in the amount of perceived volume, I guess, if you will. Kind of feels like compression to me, but it's not. It's not compression, but that's what it feels like. And then the part that really sucks about negative feedback is when it goes open loop. So when the power tubes go nonlinear, or the power transformer goes nonlinear, output transformer goes nonlinear, which is to say that what goes in isn't what comes out, the whole loop breaks down, which means all this crap here doesn't mean anything anymore. Ooh, that's not reading. I need to keep up on that stuff. Yeah, that does suck, man. I'm sorry to hear that. But, so yeah, if you push enough volume into the output section, the power tubes will then distort. And once the power tubes start to distort, because the distortion that they produce is different than the distortion that the phase inverter has, the loop no longer works anymore, right? Because they're different signals going back than what came in. And when that happens, all this falls apart, and the output section does what it was going to do anyway. And that's why a lot of people like it, when they can get it right up to to that verge, if you will, because it stays cleaner longer, and then you'll get to that point where it's just starting to get out of line, and you push it that little bit more, you give it just that little push more, and it'll break down and collapse. And that's how you can get that extra distortion, that extra bite when you dig into it. But then when you play quiet again, it settles back in and works the way it's supposed to. That's why people like it, and it's fake, if you will, because they think it's more dynamic range. It's not more dynamic range. It's actually less dynamic range. It's just that it does that thing that you want it to do, which is stay clean until you dig in and it doesn't go, it can't be clean anymore. So there's this fine line with it. Some amps do it better than others, or I guess I should say some designers work it in better than others. I am not the professional on negative feedback though, because I don't really like it. For me, the reason I don't like it, as I say, is it kind of feels like it's compressed. It feels a little stuffier, more boxed in, even though it's not. It does a thing. I don't like what it does. I like the bloom of the bottom end. Kind of like being able to tame it from the preamp or some other part of the circuit. And then the high end too, because it can tamp the high end or high frequency stuff as well. That's why the presence control is usually there, is to help open that back up again to get that presence, the air back. But it's frequency dependent. And I was talking briefly about it with Friedman. So I was saying that Marshall uses a 0.1. Well, Friedman figured out a way to do it with something else. So they use a 0.068 or something like that. It's a really small value. So they're really only letting the top air get back out, or they're only cutting a small amount of the highs out, which then allows it to be still very bright and act more like a true presence control does. 0.1 is pretty big, so it's pretty much including the whole frequency range. It's all but the lowest of the lows, more or less. So you get a lot of mids with a 0.1. So you can actually play with that cap a bit, and you can change how the presence control kind of works, or at least the frequencies that it works. The smaller the cap you go, the more high frequency air you will add compared to that of the mid and low frequencies. Golly, my apologies. Hey, James, how's it going, man? I'm glad you were able to catch it. The more the merrier. I wasn't expecting too many people today because, Andy's doing a stream right now. And he's, most of the guys that we all talk kind of with follow him, probably a little bit more so than me. But, yeah, Yeah, we're talking about it. We're going to figure it out. You're a little late to the party. We're kind of getting probably near the end of it, to be honest. But we're just talking about, design ideas, some of the, what would you call it? The compromises, right? Some of the gotchas. You can't always have your cake and eat it too, that sort of thing. So we were just talking a little bit about feedback, or negative feedback, I should say, and how that kind of plays into things. BC here, he's pretty sharp cookie. Am I correct? You do a lot of pedal design, is that correct? Or do you actually do... You're not the BC out of Canada, right? The BC Electronics? As I recall, I think I looked you up before. You're American, if I'm not mistaken. Oh, fine. Don't answer me then. I know you're probably busy. So, to kind of get back to the design a little bit of this thing, what you did miss was that I talked about going from KT88s, which I do have here. I did order them. These things are freaking bloody expensive. I think this was about $120 thereabouts, at least 100, but not cheap. And because of how little I was going to utilize them in this design, 50 watts, I mean, those things are easily capable of 80 to 100. I was thinking 50 watts is probably a little meager for them in terms of, expense, right? So I kind of started looking a little bit more into other tubes that would still do what I wanted to do. And what I was able to find out was that the KT77s would actually produce more clean headroom than the KT88s due to how they're loaded up with the voltage that I have and the primary resistance. Okay. Okay. Nice. Get into the amplifier stuff, man. I think that's where it's at. Okay, this is just a hypothesis. I don't know how true this is. I'm probably talking out my ass, but I think some of this pushback that, not pushback, what do I explain it? A bunch of the channels lately have been kind of talking about the gear review dying, and they're kind of bitching and moaning that, viewers are going away. And I think it literally has to do with that people are sick and tired of the same pedal that was made 5 years ago coming out in a version 2. And then all of a sudden, you got 10 different freaking companies that have a V2, V3, V4, V5 of the same damn pedal that's, Earthquaker Devices just recently did it. And you're probably going to be into this, BC, because you do more pedal stuff. Okay, that's cool. I don't do the repair thing. I don't want to do that. I hate PCB so much I will not repair PCB boards. But Earthquaker Devices, they're an American company. They're pretty big. They're bitching and moaning because of the tariffs and how it's going to affect them, and they're going to have a tough time paying the bills and all this yada, yada, yada. And I empathize, whatever, with them on that, because I know it does suck. But it's also how you built your business. Like, you source all your stuff from other countries. Did you not think at some point? It's not like you weren't given a lot of leeway on this. Like, Trump was pretty clear he's going to do tariffs from the get-go. So they had some time. Nice. Okay. Because there's also a BC Audio, I think is what it is, out of Canada. And he makes some crazy stuff. Like, he does literal point-to-point stuff. You should check him out. BC Electronics or Audio or something like that, out of Canada. Killer stuff. I won't do my shit that way. I'm too anal retentive that if I did it that way, I'd never finish the damn thing. But, so yeah, Earthquaker Devices going on about pricing, this, that, and the other. They're going to die. They just came out literally 2 days ago with another brand new pedal that is basically a redo of some other fuzz that's been out for the last 100 years. I was just kind of like, well, what kind of message are you sending if you're crying about not being able to source parts because it costs too much, but you've got the money to R&D and run up production and get all this fun stuff for another new pedal in your circle anyway, that isn't really new to anybody else. Like, it's just another fuzz that's been around before. So it's just another version of the same damn thing. So I was a little bit bummed. I was a little disappointed when I saw that. I think we're getting beat to death with pedals lately, and they're not cheap anymore, which is great because they're not easy to make either, as you know. So, and then to try to make a truly unique design that's not a copy of something else, not a freaking clone, not a freaking fuzz face clone, not a freaking tube screamer clone, etc., etc. Like, to do that requires some real R&D, and yeah, I don't know. I kind of see people. To me, I feel like kits are going to be where it's at here in the near future. I see more and more people going out and buying the parts themselves to build the amp du jour or pedal du jour. That I could be wrong though. Until we get this tariff thing kind of figured out, I don't know. I'm of a different opinion on that. Yeah, it is. Well, we've needed it though for a long time. I don't want to get political or anything like that, but we've needed this for a long time. Like, there was never a point ever where a guitar of the quality that they were producing them at should ever costed $150 or $200. Like, that is way too freaking cheap to literally take a chunk of wood and destroy it. Like, I feel bad. I get aggro just ruining a $20 board of walnut or a $40 board of walnut. It just kills me because I know that board is not readily available. I can't just go down to the store and get it. And then of course it's a beautiful chunk of wood, and when you fuck it up, it hurts my heart. So I can't imagine just chopping down trees and making cheap ass piles of crap guitars out of them and selling them for that price. And it just numbed us. It numbed us to that point where a $75 guitar or a $100 guitar or something like that was normal, and it's bullshit. It never should have been that way. And then some of these pedals, like I was thinking of getting into making pickups at one point in time, and I was looking around. I was like, most of these guys are able to pump these things out for about $100 a piece. I'm like, it cost me $100 worth of time just to build the things, let alone the parts and stuff. Excuse me, goodness, my apologies. But so yeah, I was just kind of like, no, I'm not gonna get into the pickup market at all. Like, I can't do it. I can barely even give an amp away. I'm blown away by this whole giveaway amp thing. I would think that, you hear the word giveaway. I've got 2,400 subscribers, something like that now. I kind of thought maybe at least 25% of them would have been like, hell yeah, like sign me up, let's go. Like, you get a free amp out of it. Like no charge whatsoever, no strings attached. You just got to play my game a little bit. And then I might have, I think since I started this campaign, I've maybe gotten like 200 or 300, thereabouts, 200 or 300 new subscribers. So that's great, whatever. But I was getting about that many anyway, so I don't feel like my subscriber count's gone up. That was kind of the hope for it, was to drive more people that way, but whatever, that's fine. That's not the whole of what I'm really doing. I need to get my product out there so someone else can get their hands on it and give some review. That's the hope, is that somebody will get this thing that plays and it produces a video. So that's the idea. But crazy to me that more people just weren't jumping on the train of sign me up. Right? That baffles my mind. So I'm a little disappointed in that regard, but I can tell you right now, it's going to make my life a lot easier coming up with a winner. And because there's only one game left, and we're not doing the game in this one. But I might have 50 to 75 tickets, something like that. And I think whoever gets this amp is going to be absolutely blown away. As far as looks goes, I don't think you can beat it. It's a beautiful amp, and it sounds really good. It's fun to play, just really fun to play. So I don't know. I could be wrong, but whoever wins this amp is definitely going to have something. And dare I say, I hope this isn't what happens, but dare I say that I'm predicting something here. PCB, oh God, yeah. No, I can't do it. No way in hell. Turret board all the way. Eyelet at the very bottom end, but turret board all the way. Oh, so is that what you do, is design some of this stuff for my matrix measure? Oh, wow. Yeah, that's a fun way to do it. So I'm predicting a future here where I give this amp away. Whoever gets it probably isn't going to like it as much as I'd hope. And they'll put it up on the market on Reverb, and I'll kind of get to see where it lands, at least in terms of pricing. Because at the moment, I can't see doing these things for less than $3,000 or $4,000. Like, it's easily, just in parts on this amp alone, I've breached the $1,500 mark. It'll be less once I get to scale, but and find ways to not fudge up pieces of wood. I messed up one of the boards the other day. Again, kind of going back to how angry I was about it, but I dusted a $40 board, and actually I need to figure out, I got 2 more that should be en route here any day now, but I have not seen them, so I need to get up on that. But yeah, I kind of feel it's like $3,000 to $4,000, so $1,500 in raw parts. Maybe I'm making $1,500 on just my time, but I've got already 200 hours invested in this thing. Most of it is in the cabinet itself. Now, I will say this, I'll be honest, in that a lot of that time is done just on the design aspect of it, because this is a new cabinet for me. I have not made it before. So, let me explain why. Have you ever had to do a repair on a PCB? If the answer is yes, then you would know. It's not fun. The traces don't last very long. You got to treat it like your baby sister or something like that. If you look at it funny, the trace breaks. If it gets hot and has any kind of burning on it from a part that failed, you're going to be redoing traces. Generally speaking, they use ribbon cables that come out, and some of the amps that you can buy today don't use connectors for those ribbon cables. They solder it straight into the board. So every time you move that thing is one more bend that might break the solder connection that those ribbon cables go in through. I've had an instance like that before. What else? Jacks Input jacks should never have ever been designed to go on a PCB ever in their entire life. I can't tell you how many input and output jacks I've had fail where it's just, cold solder. Another problem is most PCB designs are using unleaded ROHS and CE approved and all that fun stuff solder. And that non-leaded stuff just freaking blows, right? Most of them also use low heat solder or lower, melting point solder. And that shit just is doo-doo. So, yeah. If you've ever played around in a Mesa, you don't want to, because they've got boards that stack on top of boards that are all everything everywhere. And if you have to get to so imagine this, let's say that the part that you need is down underneath that third layer of board down there. You're ripping all of them out to get to that one part. Not fun. Turret board, it's pretty evident which part burned up because you can see it. It's on the top. So you can cut it out, solder it out, whatever you got to do. And the turrets, because they're not, they're mechanically attached to the board, it's really hard to burn up that G10. I don't think you can burn a G10 board with solder or a soldering iron. Can't get hot enough. So you can, the service life on a turret board is nearly infinite, if you will. Some of them are better than others. So here's the thing. PCBs, a very well-designed one, as you guys probably know because you do this kind of stuff, but a very well-designed PCB board does not have any sound detriment to it. It's not that it sounds bad. And in some cases, if it's even better well-designed, it can be quieter and better designed than a turret board layout of any amp that you can imagine, right? So it can be done. But most companies are not going to pay that kind of money to do all the research and development and do things to that level. Most don't. I've seen some work where they actually have ceramic PCB, layered ceramic, and then the traces are built into the different layers. So you can have a 3 or 4 layer ceramic circuit board that has all the components integrated into it, et cetera, all the traces, and it's crazy. You can't burn this thing up. But the amount of work that goes into designing it and making sure that parts don't interact with each other, et cetera, is hundreds and hundreds and hundreds of hours. And then you got electrical engineers doing all kinds of stupid testing where something as silly as, the coating on the wire that they use to run from here to there affects some high frequency thing that goes on and destroys, makes the machine not reliable or something like that. A friend of mine who I built the Purple Hazel for, he's an electrical engineer, and that's one of the stories he was telling me is that they had this problem, and it was high frequency related, and he did all this, whatever type of stuff he had to do, and he ultimately asked the one of the manufacturers that they were getting supplies from that, what's in that red colored wire that you have? Is there any kind of iron in it? And sure as shit, the coloring that was in the wire derived from iron. And that was the cure for the problem that they were having. Stupid shit like that. PCB, that's where it happens. Turret boards, not so much. You just make sure you don't put your wires on top of each other. That's it. I have not. How do I explain it? So there's only 3, now maybe 4 manufacturers of tubes these days, modern today. Maybe 5 now. But there's EHX, Electro-Harmonics. They make 5 different brands. You've got JJ's, you've got Shagwong, whatever the hell they are, and then you've got PS Vane or whatever. So maybe those 4 different companies. Before PS Vane came along, there was really only the major 3. So if you're buying a brand new tube now, it came from one of those 3 companies. Doesn't matter if it says Ruby, Mesa, Fender, Groove Tubes. It doesn't matter. Most of them will kind of tell you Tube Depot puts their sticker on it, but the tube is obviously straight up from JJ, right? I got a set coming They're coming from Tube Depot, but I usually get them from Antique Electronic Supply. But in either case, all right. So there's a 33.33% or now a 25% chance that if you buy a tube that has a name that you like on it, it's probably coming from one of those 4 companies. Even if it doesn't say JJ, EHX, PS Vane, or Shagwong or whatever. Yeah, right? They can be. They certainly can. I don't know, man. I've seen some of them, like even Diesel, who's been doing it for probably longer than those guys have. I can tell you now, like Headfirst, I like him as a person. I kind of feel it's a bummer that he's basically the next Friedman. Friedman is using eyelet boards. Realistically, it's an eyelet board. That's what it is. It's a PCB trace with eyelets on it, period. That's what they're doing. Sur's doing the same kind of thing. They're well designed. You know, they're thick PCB, double tracing, and all that stuff. And you know, the glue stuff that they use, the red or the green colored crap that overlays everything. Really nice. It's not that they're bad. Fuchs, I don't know much. I haven't seen inside of one, but I know that they're or Fuchs or whatever. I'm pretty sure it's Fuchs, but in either case, I've seen his stuff. Most of the stuff's going to SMT now. I got a freaking pedal from them. I was very disappointed in, by the way. It's all SMT, and it was supposed to be this rare and unique pedal that they were only going to make so many of. And then they expanded the line out like 5 different versions of it, and now they're everywhere. I'm like, bullshit. Your VHX, right? Are you VHX or VHT? So the VHTs are still on. Yeah, they're not PCB, but they're kind of done up semi-turret board style. It's not that they can be bad. It's just when they go wrong. Like if you look at a Fuchs, they got a lot of layers. There's a lot of shit going on in there. How many times are you going to repair it before it is no longer repairable? Depending on what goes wrong. Because any amp where they PCB mount a freaking tube, I will not buy ever again. Period. If you have an output tube that decides to dust itself, it's taking out the turret or the PCB board with it. Period. If you've got one that burns up a screen grid resistor or something like that, it's going to take out something else next to it. Period. Every damn time. If the freaking power tube goes, it's taking something with it. Mesas are famous for it. And there were some that would probably argue that Mesa's great too. They're great while they work. That's all I can say. They're amazing when they work. Oh, Diesel. Okay, yeah. And Diesel's great too. Like they use nice stuff. Wima's okay. Now don't get me wrong, but it's still pennies on the dollar, right? It's not the best stuff that they could possibly get. It looks good because it's well designed, but it's still, if something goes wrong, which eventually it will, you're going to have to repair it, and it's very, very difficult to do the work, especially if the thing that you need to fix is way down on the bottom, on that third layer of freaking PCBs that they got. And then trying to do, like, assessment, right? So let's say you're trying to find the hot resistor that's causing your channel switching to not work right or something like that. Like, if you don't have a thermal gun, how are you going to do it? Especially since you can't get down to that third layer and see underneath all that crap or something like that. Fuchs is like that with a lot of their stuff. They're multi-layer. And sure, it looks pretty, but it's only good when it works. And certainly, there is no argument that can be said that working on PCB is easier than working on a turret board. However, there's so much more you can do on a PCB, like all the channel switching and all the fun stuff you can do. Like, yeah, you can't beat an amp that has all the MIDI crap and stuff in it like that. You can't compare it, I guess. But I digress. So we got to some of the gotchas, at least in that regard. You can probably tell where I land. But I get it. Like pedals for sure, all day. Like they have to be PCB. Like you can't do turret boards and pedals. And ask me how I know because I did it. It's very difficult to fit all that stuff in even a normal dual gang size box. Yeah. Well, I can't remember what it was I saw. There was somebody that was kind of going on about what you're talking about there, current flow, width of the trace, and such, and like dealing with the ground planes and stuff like that. Well, some of these like individuals don't realize that putting ground planes next to other things just leaves yourself open for problems. It comes down to just proper design, but I don't know. I mean, most people aren't going to go take a turret board, or excuse me, a PCB board, and create a jig that all the test points can go into, and then throw as much current into it as they can to see where it fails at, or what kind of other anomalies happen when it does do something silly. Yeah, and then pots and jacks and tubes should never, ever, ever touch a PCB. Period. That is just a personal opinion, though. I would love to. So I have that one design right now for the pedal. I would like to kind of see where I could go with it with SMT. I'm not going to say I'm a PCB designer, but I don't know if I'd go SMT level of small with it, but I would definitely look into at least, mounted components like that. But it's funny where some of them end up, though. Like, it just depends, I guess. There's all kinds of depends. That's just it, too. There's so many. It's kind of like a Ferrari, I guess you could say. So I have a friend that works with those types of cars, right? Classic cars and sports, European sports cars. And he's all, the problem with Ferraris is that they don't have a problem for a very long time because nobody drives the damn things. So, a car might be 20 years old and only has 2,500 miles on it. Well, what happens is over time, all of a sudden, they start having this one problem. And it just finally took that number of miles for that problem to become a reality. And then it's too late to do anything about it because they're no longer making that car. They don't have the parts for it anymore because they never made it because it never broke. But now you've got a plethora of these, Ferraris with very expensive engines and parts and this, that, and the other that are suddenly starting to break. And then somebody has to come along and re-engineer it. So I guess it kind of comes down to that thing is like, how long can it go before it starts becoming a problem? I try to weed out some of that stuff. That's why my amps literally live on, 100 most of their life while I have them anyway. When they're turned on, they're plugged into some sort of a load box, and I'm trying to. I cannot get my amps to break. I've I probably tripped out my friend. I gave him one of my amps to borrow for damn near a year, and when he played it, that thing only ever lived on full blast. He always ran it through a load box. And while I had it, it always ran through a load box. And the tubes in it are easily going on 5 or 6 years of age. Easily. And he's like, I feel bad. Like, I'm flogging on it the whole time. I was like, dude, I need the freaking thing to break. Like, I need to find out what's going to take a dump on these things. Can't do it. Can't figure it out. They just last for freaking ever. So that's what I try to do is design it so it's just bulletproof. Like, if I can't touch a part immediately after the amp's been turned off, and it's safe to touch in there, right? In terms of electricity, and then I got to figure out how to make it so it's touchable. So I like running things pretty conservative. So if I need a 5-watt resistor, and that's probably the sane resistor to use, I'll use a 10-watt if it calls for it. Power supplies, I'm not that worried about. Generally, I don't have an issue there. The HT rail. So I find that 2 to 3 watt resistors in there the whole way is generally fine. Like I haven't had any problems, especially once you get past the screens. Yeah, I would agree with that. Amps get a lot more vibration. They get beat up a little bit more. And there's only one way to do it, I guess, in those things too. I guess you could still probably mount the jacks off the thing, but yeah. Well, and now the mini pedals that they're coming out with, where the jacks almost literally cross each other, it baffles my mind how they came to that conclusion. But Most of those are PCB mounted, I think, aren't they? I think they'd have to be. Maybe it's not so problematic for them because everything's so like compact, but it's pretty hard to break something that small. At least I feel anyway. So many are questionable though. I always find it funny when you get like the SMT stuff where they build it in the same size pedal as the original design, and it just looks like there's nothing in there because all the parts could literally fit in something the size of your finger, and then they have that whole board still to use, and I find it funny anyway. Maybe I'll bust out that Fuchs pedal that I got. There's not a whole heck of a lot going on in it. There's still a fair amount of circuitry for something that's pretty simple, but it's all SMT. They use that purple color stuff. I always get annoyed when you can tell that the aesthetics of the PCB trace or PCB design was more about aesthetics than it was actual function. You see those ones that like put funny shapes into the PCB, and then what do you call it? Like they'll use like the nice flowy shapes and stuff like that. You know, like Pac-Man or something. Still, yeah. So that's how I used to be. When I first started playing guitar, I couldn't afford the big amps. So the only thing I could afford was like the multi-effects boxes. So I got like a 120 watt crate, a pile of dog shit, but it had a nice clean anyway. It did clean. So, it was a cheap enough amp, and then I bought one of those Zoom 2020s. I think I have it somewhere still. I might still have it. Sold it once, and then it went to I found it one day in a music shop. The same pedal that I had sold many, many years ago. Found it one day in a music shop. Bought it back for pennies on the dollar. And then sold it again to someone else, and then I ended up getting it back still. So I've reacquired my same pedal twice, that Zoom 2020. I might still have it. I don't know. But in either case, that's how I did it. It sounded like shit, to be honest. And then I kind of got into getting other pedals and stuff like that. But then I started having problems when I went with multiple pedals where connections. This is before like the little, 6-inch things were starting, really well designed. They were always the fat freaking cables, and they were cheap piles of crap. So I started having problems, and I got fed up with it, and I said, forget all these pedals. I'm going guitar into the amp. If I can't get the sound I want, forget about it. So yeah. Yeah, right? I always had nice guitars, though. I was spoiled in that regard. So my first guitar was a Samick, which Samick at one point in time is kind of like Cort is today. Like they literally made like 55% of the guitars out there. Amazing guitar. Made out of plywood, mind you. And I have a Fender Squier, or a Squier 2, I guess you could call it. I call it Fender because it looks like Fender, but also made out of plywood. Probably made by the same factory that made the Samick, to be honest. But both of those great guitars. But then I found somebody. I was a mover at one point in time, so I was moving somebody, and he was in the Air Force or whatever. And he had this guitar in his closet, and I hit him up. I was like, "Hey, man, are you interested in selling your guitar?" And he's like, "Well, actually, I kind of am." And I was like, "Well, how much do you want?" He's all, dude, give me $50. And I was like, sold. So I scrounged up $50, gave him the $50, and got that guitar. Turns out it was a 1969 Cameo Deluxe, which is a Japanese-made guitar. Probably still made out of plywood or something like that. It's not a very pretty guitar, but it looked like an SG. Plays amazing, sounds amazing. It has a 0 fret. It has a bunch of things that don't come on normal guitars. Amazing guitar. But yeah, for $50, I got a vintage guitar. And then I picked up a lot of my guitars are 90s era guitars, it seems. I have an SG, an Epiphone SG that's 90s era. That's an absolute pile of shit. But both of my Strats, the Samick and the Squier 2, are 90s era, made out of plywood. Baffles my mind because the Fender one actually sounds amazing. And I swear to God, the neck on that thing was probably the best neck I've ever touched. It's got that really nice thin C profile, and it's just straight as an arrow. I don't know what it is about that neck. I can get to about 75 thou or something like that, or 0.075, whatever that is, um, off the strings. Like you put your finger down and it plays. Like it just amazing guitar. What else? I have a bunch of vintage guitars. I have quite a few vintage guitars. My aunt gave me a 12-string guitar that's probably older than me. I think she said it was a mid to late 60s era 12-string. I can't even remember the brand of it right now, but amazing guitar as well. Needs some love, but whatever. I'm spoiled in that regard. Now I just build my own guitars. I find it just to be a little bit easier to get what you want when you just build it yourself. Oh, damn. All right. So I was thinking about getting into buying vintage amplifiers several years ago before it became like the big thing. Like I remember like a GA20, or Gibson like GA15 or whatever, the little Gibson amps. I was looking at them and they were like $200 or $300. Now you can't even find one for less than like $500 or $600 or $800 or something like that. It's insane. And then Fender, like Princeton's, they used to be like $300 or $400. Now they're like $1,000. It seems. It's just like, oh my god, like I should have jumped on them. I was never into small amps though at that point in time. In that era, I was still into the larger, 50 plus waters, and yeah, I kind of fell out of favor for them. Once you know, you know. A fat D. So that you'd probably like my Telecasters that I have then. Both of them have like a big fat like D style neck. They're almost like a baseball bat. I don't mind them. I like them myself. But I kind of like the thin C if I can find them. But they're just easier to play. That's all. Ooh, okay. Vintera series, yeah. I tried. So here's the thing. I picked up a recent. Maybe I don't know if it was Vintera, but it was like their American Classic. I was so disappointed with it, the Fender stuff. You could tell that they put the finish on with the nut in there. So they installed the nut and then finished the guitar. I was just like, what? That just made no sense to me. And to me, it just cheapened it a lot. And then they had one that was trying to emulate like a 50s like V-neck. That one didn't feel very good either. Didn't play right either. It wasn't right. Something wasn't wrong with that one, but I was just like, you're trying to make all these nice vintage guitars, but they just can't seem to do it right. And I know it's not because they can't. I just know it's that they won't. They won't. Yeah. I was very disappointed. So at one point in time, I had like one of those Sears catalog guitars. It was one of those wacky designs. It was literally made out of a piece of pine or something like that. I shouldn't have ever sold it. It had a wooden bridge and it was broken and it looked like it was made out of walnut or something like that. So it didn't play right, couldn't intonate it, and it just like the pickups were, this is way back in my earlier days. Such a cool guitar though. It would have made just a nice wall piece. And I shouldn't have sold it because I sold it for way too little. One of the most expensive guitars I have is Fender Schecter, like Diamond Elite series. Killer guitar. It sucks that the flame on it is veneer. That's the only part that really bums me out. It says that it has a ebony fretboard, and I do believe that it's really truly ebony, but I don't know if it's a veneer or not, because they do have what do you call it, the piping, I think it's piping, whatever, the edge that they put on, binding, excuse me, they do have binding on the neck, and it actually is maple binding, which is great because it contrasts really well. But I don't know if they're faking you out by just putting like a thin veneer of ebony in there, or if it's a full thickness of veneer and then they just happen to actually use the maple like binding on it. Beautiful guitar. I don't like the way it sounds. I want to try to get, it has a Floyd Rose in it. One of the best Floyd Roses I've ever come across, but I haven't found a set of pickups yet that I like, and it's kind of a shame. I think when it was new, it was like a $1,200 guitar, and it feels like a $1,200 guitar. I picked it up for about $600, so I was quite stoked with it. But because of how it sounds with the electronics that I've had in it so far, I will never ever buy a guitar sight unseen. I bought it from somebody on eBay, but I will never buy a guitar sight unseen and not plug it in first to see if something's going on. This one has like a weird kind of honkiness to it, and I think part of it's the Floyd Rose and just the body wood. I think it's poplar. I could be wrong. I know it's got a flame maple top, but it's a veneer. I know it's a veneer. But I can't remember if the body is poplar or alder or something like that. It just sounds kind of, has a mid-rangey nasalness to it. But the neck on that thing is amazing. Definitely one of the better playing guitars I have. But because I like to bend the strings a lot, it's not something suited very well for Floyd Rose. I'm not a Floyd Rose kind of guy, I guess. Yeah, if you can understand circuitry at all, it doesn't matter. It's still the same. It's just you're scaling up the voltage. So you're going from 9 volts and maybe a buck converter or something like that to get you somewhere else. And maybe to bump it up to 18 volts or whatever. Whatever. Same kind of crap, If you can read the schematic to make some of these pedals are more, that 4x4 matrix thing you were talking about. That's a guitar amp is, child's play compared to some of that crap. So yeah, definitely. And then just start small. Like if you're worried about complexity, Fender Champ 5F1, like it's hard to beat that circuit. It's a great circuit, sounds great, period. And it's I think the BOM for it is probably less than 50 parts, thereabouts, maybe. And that probably includes the cabinetry or a 5E3. This 5E3 I have that we've been talking about a lot on this channel, is the BOM on that is probably, it's less than 75 parts probably. Not including the head shell side of things, but I think I can get it. It's probably 50 parts to 75 parts, so it's not that bad. And the circuitry, like the schematic on them is easy as pie. Like you can almost look at it and instantly pick up what it is. Now, if you're trying to get into channel switching and reverb and, all that other kind of stuff, like, yeah, you probably, not a good candidate for first build. Oh, if you can do a buffer, you can do a guitar amp any day of the week then. Princetons are great. Like, that is the amp. I'll have a Princeton design at some point. It's kind of similar to a 5E3 in some ways, but I think it's a little bit more refined. It does the thing a little bit better. It is a little lower wattage though. So mine, I did some math on it. I'm pumping out, I think it was 15 watts is what this one will produce. So somewhere between 15 and 18 watts. So it's producing a little more output power, interestingly enough, than an actual 5E3, which I think was rated at 12 watts or something like that. So I don't know. Fun amp to play though. But you guys, I think we've kind of reached that point. It has been just about 2 hours on the mark here. I am out of beverage, which is breaking my rule about always having a beverage of choice within arm's reach at all times. We've kind of gone over all the talking points I wanted to get to. We've answered some questions. And I need to go spend some time with the wife because I'm sure she's going to get fed up with me really quick, especially with this week being the way it's going to be for me. I want to thank you all so much for joining me. I can't wait for the next one. I probably will not have a video out this week. I suspect next week, middle of next week, I might do another live on Monday just for the S's and G's. I think this is something I'm going to try to do at least once a week, right about this time frame, somewhere between 6:30 and 8:30 kind of range. James, thank you, man. I appreciate you coming. And yes, thank you for the hang. And my hope is that this amp will be done. I'm pointing at it right now. It's in front of me. My hope is that it'll be done and we can actually, give it the expose, if you will. That's the hope. I don't know for sure. Do turn on the notifications. I was just saying next week, hopefully. That's the plan. Probably Monday or Tuesday at least right about this time, 6:30 to 8:30 time frame. I think if I make the post, because I try to schedule it at least a half hour ahead of time, I think if you have notifications turned on, it will send you a little blurb saying, hey, homeboy's doing something. Do you want to wait in queue or whatever? That's what I've noticed, that there's usually at least one or two people that will be in the queue waiting for the video to start. So that's kind of cool. So that is something to do if you're interested. I do need to find a way, obviously, to schedule this more, what's the word for it? Repetitively, like every Monday at 6:30 or something like that. I'm trying to find a way to fit around all the other channels that are out there. The Brad the Guitarologist has kind of a thing going. Psionic Audio has his thing he does on Saturdays. Head First does kind of a thing. All of them kind of have a day and a time that they do it, and I'm trying to find kind of a spot where I fit in to all that. Andy Lederman, obviously he's live all the time, so there's no time that's good to fit around him. But I'm trying to figure that out. So it just seems that 6:30 to 8:30 works pretty well. Although I have noticed in times past that I get a little more action a little bit later, like for my time, like between 8 and 10, which is kind of interesting. So in either case, thank you all so much. I'll see you on the next one, probably, like I say, this time next week. Take care. Goodbye.